First question. Calculate the oxidation number of sulfur in following molecules or ions. So here we have H2S. Hydrogen has oxidation number +1 in all of its compounds except the hydrides of group 1 and group 2 elements. So hydrogen has oxidation number +1 except in group 1 and 2 hydrides. For example, if it is lithium hydride, lithium will always have +1, hydrogen will have -1 in that case. For example, calcium hydride, calcium will have +2, hydrogen will have -1. Otherwise, in all the compounds, hydrogen will have +1 oxidation state. Hence, here also hydrogen will have +1 oxidation state. So sum of all the oxidation states will be 0 because overall H2S does not carry any charge. Hydrogen, 2 hydrogens, and the oxidation number of one hydrogen +1, 2 times +1 plus sulfur, assuming it is X, sum of oxidation states will be 0, X will be equal to -2. So here the oxidation state of sulfur will be -2. Next, H2SO3. Here also we need to calculate the oxidation number of sulfur. Sum of all oxidation states will be 0. So we will do 2 hydrogens, 2 times +1 plus sulfur, let it be X, plus oxygen. It is normal oxide. Remember, oxygen has oxidation number -2 normally in its compounds, except if it is a peroxide or superoxide, or it is oxofluoride. In these cases, the oxygen will have different oxidation state other than -2. So peroxide will be of the type of Na2O2, H2O2. Superoxide will be of the type of KO2, RbO2. But here it is normal oxide. It means the oxidation state of oxygen will be -2. But we have 3 oxygens, 3 times -2. Sum of all oxidation states will be 0. It means it will be 2 plus X minus 6 equals to 0. That is, X will be +4. Oxidation state of sulfur in H2SO3 will be +4. H2SO3 is sulfurous acid. Next, sulfate ion. Sum of all oxidation states here will be -2 because it is ion. Sulfate ion carries -2 charge. Sulfur, let it be X. Then you have 4 times oxygen -2 equals to sum is the charge. Overall charge is -2. It means X minus 4 to the 8 equals to -2. X will be 8 minus 2, that is +6. So in sulfate ion, sulfur will have oxidation state +6. Next, Na2S2O3. Here sodium will always have oxidation state +1 in all of its compounds, no exception. Group 1 elements always +1. So sum of all oxidation states here will be 0. So in this case, 2 sodiums, so sodium +1, 2 times +1 plus 2 sulfurs, say it is 2X, then 3 oxygens, normal oxide, so it will be 3 times -2, sum will be 0. It will be 2 plus 2X minus 6 equals to 0. 2X equals to 6 minus 2, that is 4X will be 4 by 2, that is +2. So in Na2S2O3, the oxidation state of sulfur will be +2. Next, S2O7 2-, it is ionic form. It means whatever is the sum of oxidation states of this part will be equal to the charge -2. There are 2 sulfurs here. So if the oxidation number of sulfur is X, it will be 2X plus 7 oxygens. 7 times -2 will be the charge here, that is -2. So 2X minus 14 equals to -2. 2X equals to 14 minus 2, that is 12. X equals to +6. It means the oxidation number of sulfur in H2O7 2 minus ion will be plus 6. Next, H2SO4. Now remember, H2SO4 and SO4 2 minus, these are actually same thing, because you can dissociate H2SO4 as 2H plus SO4 2 minus. So effectively, whatever oxidation number of sulfur you are calculating in H2SO4 is same thing as you are calculating oxidation number of sulfur in sulfate ion. But here you will calculate it differently. You will say that sum of all oxidation states will be 0 because overall there is no charge on H2SO4. Here you said sum of oxidation states of SO4 2 minus will be equal to minus 2. So in H2SO4, 2 hydrogen plus 1 plus sulfur X plus 4 times oxygen minus 2 equals to 0. Remember, hydrogen will have oxidation state plus 1 because it is not group 1 or group 2 hydride. Oxygen here normal oxide, so minus 2. So 2 plus X minus 8 equals to 0. X equals to 8 minus 2, that is plus 6. Next, S2O4 2 minus, sum of all oxidation states here will be equal to minus 2. So sulfur we have 2, we will say 2X plus 4 oxygens equals to total charge minus 2. 2X minus 8 equals to minus 2. 2X equals to 8 minus 2, that is 6. It means X will be 6 by 2, that is plus 3. So oxidation state of sulfur in H2O4 2 minus ion will be plus 3. What is the oxidation number of the underlined atoms in each of the following molecules or ions? First one is ClO3 minus. Sum of all oxidation states will be equal to the charge. So if chlorine's oxidation number is X, we will say X plus 3 oxygens. O3 means 3 oxygens. 3 times minus 2 equals to overall charge minus 1. X minus 6 equals to minus 1. X will be 6 minus 1, that is plus 5. It means oxidation number of chlorine in ClO3 minus will be plus 5. Next, BrF3 minus. Here we have to calculate the oxidation number of bromine. So it will be bromine, let it be X plus 3 times. Fluorine always has oxidation state minus 1 in its compounds, no exception, will be equal to 0 because overall there is no charge on BrF3. It means it will be X minus 3 equals to 0, X equals to plus 3. Bromine will have oxidation state plus 3. So you can notice here that halogens, although being electronegative, other than fluorine, can have positive oxidation states. Fluorine can never have oxidation state other than minus 1 in its compounds. In elemental form, free state form, all elements will have oxidation state 0. But in its compound, fluorine will always have oxidation state minus 1. In elemental form, obviously 0. Other halogens can have oxidation state positive as well. Next, CH4, we have to calculate oxidation state of carbon. Let it be X plus 4 times hydrogen plus 1 equals to 0, X equals to minus 4. So carbon here has oxidation state minus 4 in methane. Next, C6H12O6. This is formula of glucose or fructose. Because fructose also has the same formula, the structure is different. You will study it in organic chemistry. Sum of all oxidation states here will be 0. We have to calculate of carbon. Let it be X. But we have 6 carbons. So 6X plus 12 hydrogens. Hydrogen has plus 1 normal oxidation state in its compound plus 6 oxygens. Oxygen minus 2 times 6 equals to 0. Overall, there is no charge on this molecule. So 6X plus 12 minus 12 equals to 0. So 6X equals to 0. X equals to 0. It means oxidation number of carbon in C6H12O6 will be 0. Next, we have to calculate oxidation number of boron here in Na2B4O7. Again, it is a molecule, no charge. It means the sum of all oxidation states will be 0. Sodium will always have oxidation state plus 1 in its compound, but we have 2 sodium, so 2 times plus 1. plus boron we have to calculate. We have 4 borons, 4x plus 7 oxygens, 7 times minus 2 equals to 0. We have 2 plus 4x minus 14 equals to 0. 4x equals to 14 minus 2, that is 12. X equals to 12 by 4, that is plus 3. So boron in Na2B4O7 will have plus 3 oxidation state. Next, this is a complex compound. We will be talking about these type of compounds in 12th grade coordination compounds chapter. Here we have to calculate the oxidation number of iron. Sum of all oxidation states will be 0. We have sodium here, 4 sodiums, so it will be 4 times plus 1. Sodium oxidation state always plus 1 in its compounds. Then we have iron to be calculated as X plus 6 times Cn, and Cn is cyanide. So for example, you have KCN. KCN will get ionized as K plus and Cn minus. So you can take the oxidation state, oxidation number of cyanide ion as -1. So you don't need to write oxidation state of carbon and nitrogen here. Remember, if it is cyanide, you will use the oxidation state -1. But we have 6 cyanides, it means it will be 6 times -1 and sum will be 0. We will have 4 plus x minus 6 equals to 0, means x equals to 6 minus 4 equals to 2. So iron will have oxidation state plus 2 in this complex. Next, N2H4. Again, no charge. So sum of all oxidation states will be 0. Nitrogen we have to calculate. 2 nitrogens, we will say let it be 2x plus 4 hydrogens, 4 times plus 1, sum will be 0. 2x will be minus 4, x will be minus 4 by 2, that is minus 2. Oxidation state of nitrogen in N2H4 will be minus 2.